Hey everybody, welcome to the next installment of Statistics in Pajamas and our first foray into inferential analyses. So in this video we're just going to cover really quickly the different steps involved in an inferential test, any inferential test. They all really follow the same set of steps that you have to work through to come to a conclusion about whether or not you have a significant result. Now we're going to work through these one at a time, so don't worry about writing all these down. Really, the first thing that you have to do, once you've already gone out there, you've designed an experiment, you set up your sampling strategy, you've collected data, how do you actually run the inferential test? Well, the first thing you have to do is make very clear what your null hypothesis is. And remember that all of our statistical tests, all of these p-values that are returned, are really testing the null hypothesis, which is why it's so important that we know what the null hypothesis is. And really, the null is always very boring. It's the one that sounds awkward if you were to state it, right? It's always more interesting to say what your research hypothesis is. But the null is just saying that there's really nothing, there's no significant result going on here. There's no differences between groups, there's no relationships, there's no way that I can model this. All of the variability that we see is just due to random chance alone. And you're going to see this null hypothesis symbolized by this H sub naught. And each of our different tests is going to have a different way of symbolizing what that null hypothesis is. Okay? But this is just important for us to state up front because it also helps us to figure out what test we're going to run. I know that it can be confusing interpreting those p-values. Remember that the p-value is what we're ultimately trying to calculate with our inferential test, and it tells us the probability that our null hypothesis is true, right? And so it's a little counterintuitive, but really the smaller your p-value is below your critical value threshold, usually set at 0.05, right? The smaller that p-value, the more significant your result. So again, it can be counterintuitive, but if you keep in mind the p-value is reporting the probability that that null hypothesis is true, that might help you out. And you may hear me or others or read in other textbooks, they refer to this p-value as either the significance level, you'll hear it referred to as an alpha level. Some people call it type 1 error because that's what it's actually calculating, is your risk of a type 1 error, right? The chance that you're going to say there's a significant result when really there isn't. Some people will just refer to it as a probability. Right? So either way, this is really the key that we're trying to get through or get to with these inferential tests, is to calculate a p-value that we can then interpret to figure out whether or not we have a significant result, which is whether or not we can accept or reject our null hypothesis. As I mentioned, the null hypothesis really lays out what variables we're testing and what type of relationships we think don't exist. Right? There is no difference in the means between these, or there is no correlation between these variables. So that helps us identify what test we're going to run. And there are so many different statistical tests. There are new ones being created every year that it can be kind of complicated to figure out what the right test is. But don't panic. That's our mantra in this class. We never panic. We will be going over the criteria for each of the different common analyses in our field, so we'll know when to run those common ones. And then even when you get into more complex analyses, there are these really nifty dichotomous keys that you can use to help you figure out what type of test you should be running.
And we do go over some of those different keys and tests in our other video.
The next step is to set the level of risk that we want to use for this actual significance test. And when we're talking about setting the level of risk, we're really saying, what's the p-value threshold, or it's at alpha, the level that we're going to be using. Usually you set that to 0.05, but you can adjust that down or up depending on how much power you have to your test. And that's perfectly justifiable. The reason why this is in here as a specific step is because it keeps us honest. Right? If, for example, you know you have a test with a lot of power, and you really should be using 0.01 instead of 0.05. You should state that right up front, that I'm going to use 0.01. And what it does is it keeps you honest, because then if you end up calculating a p-value of, say, 0.04, you won't be tempted to go, oh, I changed my mind. I was using 0.05, right? It's a way of saying, you know, I know the power of my test. I've assessed that as a part of my experimental design. So I'm going to use this p-value threshold, and I'm going to stick with that. Okay, so it really is how we're just setting up for what our interpretation is going to be based off of. The next step is to actually compute the test statistic, and every test has its own formula. So depending on if you're looking for differences, or you're comparing a mean to a population, or you're looking for relationships, each of these different types of research questions has an actual equation that quantifies that difference or that relationship. And essentially, they're all just like z-scores. They're that statistical translator that's taking all of your data and it's looking to see where along that probability distribution your result falls. Now, we call this the obtained value. Okay, sometimes we also call it the calculated value. Sometimes we call it the test statistic. They're all the same thing. It's you actually doing math with a formula that's quantifying whatever it is, the test that you're trying to use. And which formula we use was determined back up here in step 2, right, when we identified which test it was that we were using. The next step is to find a critical value to compare our obtained test statistic to. Right? So what the critical value does is it's actually saying, based on that probability distribution for this specific test, okay, what value would I have to beat in order to fall into this tail, this would be for the one-tailed test, or to fall into either of these tails for the two-tailed test. So if the obtained test statistic that I calculated, right, that's what it falls in this normal distribution curve, right, that test statistic is now my x-axis. And if what I've calculated is more extreme than that critical value, then I have a significant result. Right, or for the two-tailed test, if what I've calculated is more extreme than that critical value, I know I have a significant result. So now once I've calculated my obtained test statistic and I've determined my critical value, now I can compare the two. And this is how I'm ultimately going to figure out whether or not I have a significant result. If my obtained value that I calculated is more extreme than that threshold, that critical value threshold, then I fall into the region of significance. I reject the null hypothesis. I know I have a significant result. But if my calculated obtained test statistic falls somewhere in the middle, that's not as extreme as that critical value threshold, then I have to accept the null hypothesis, right, or fail to reject it. And I know that I do not have a significant result. And that really was it back in the good old days, back before computers and calculators and software. But we can take it one step farther beyond just saying, yes, we have a significant result, or no, we don't have a significant result. We can actually report the exact p-value, right? So we could come back and we could say, oh, well, if I calculated my obtained value right out here, right, well, then that's associated with a p-value of, and you can actually state exactly what that p-value is. JMP will give you those results automatically, but you can also get them in Excel, and each test has a different function that will return the p-value for its own test. And we'll go over each of these as we go over each of the tests. So now you've compared your obtained value to your critical value, and it's just time to conclude. And we've already talked about whether or not to determine significant or non-significant results. But again, just because it's confusing, I want to reiterate, if you have a p-value that's larger than that threshold, that p-value threshold that you set, right, that alpha level, then you just have to accept the null hypothesis. The null is true, there is no significant result. But if your p-value is small, and by small it's got to be less than whatever that p-value threshold was that you set at the beginning of your analysis, then you can say it's really unlikely that I'd be calculating this value just due to chance alone. So there must be a significant result going on. So I have to reject the null hypothesis and conclude that there is a significant result to this test. But it doesn't end there, right? In addition to correctly picking the right test, calculating the right test statistic, identifying the right critical value, coming up with your p-value, and determining whether or not you have a significant result, you also have to communicate your results, right? And this is just as important as actually getting the right answer.
And I am going to put that in a separate video so that you can refer back to it often, how to succinctly summarize your statistical results. So look for that in a separate tidbit of wisdom.